we do have one more attack called as DNS tunneling attack. Let me specify that one. Let me delete all the things. So do you remember how the DNS works actually? We have discussed about DNS spoofing also. We have discussed about DNS, how it works. We have discussed about DNS spoofing as well, right? What is meant by DNS spoofing? Unauthorized DNS access, right? The server, whatever the DNS server automatically, if you are making a request, right? The same at Amazon.in, okay? If I say, okay, if I am making a request because the server okay cannot understand the domain name Amazon.in, it can always understand IP address. So what it will be doing, whenever it receives a request, it will be checking for the IP address, so it will be sending to the particular DNS server, correct or not? So like that it will be identifying. So in DNS spoofing, what the attackers will be doing, so when in your system, because it is a compromised system, they have already entered into a system, they will be changing the, in general it is a automatic process, okay? So because why it is automatic, all those things we have discussed actually. So for the first time it cannot know the IP address, okay? For the first time it cannot know the IP address. So at that time what it will be doing, let me explain. So this is your network, okay? So mydomain.com, okay? So in my network I do have a several computers, okay, several laptops, okay? This is my laptop, okay? This is my desktop, this is my printer, okay? This is my printer. So now for the first time, so roughly I'm drawing, okay? So because already we have discussed, so what for the first time it is accessing, what it will be doing, where it will be checking, Eunice, where it will be checking, where it will be checking,
DNS,
internal DNS, okay?
internal
So
DNS,
yeah, so internal firewall will be having, first of all over here, okay, internal firewall, okay? So short forms only I'm writing, internal firewall, okay? And again we will be having DNS. This is the internal DNS, okay? So firewall, from the firewall to DNS it will be checking. So for the first time, because there will be no entry in my internal DNS, okay? So what it will be doing, it has to go out only, right? So here my particular, what is this, Eunice, what is this
Same DNS.
before that? That's why I asked you before DNS. This is my DNS. Whatever my domain DNS is there, it will be going, it will be checking in my domain DNS, my domain.com, right? In my .com, it will be checking. Okay, so it will be checking, or else the IP, the service provider DNS, it will be checking. Okay, so here it will be checking. Okay, it is a perimeter firewall. It is perimeter firewall. Before this one, it has to enter through a perimeter firewall, right? Before that, this is my, this entire thing is my domain. Sorry for my drawing. Okay, this entire thing is my domain. So here I'll be having a perimeter firewall. So here the whatever the particular service provider domain is there, right? DNS is there, right? It will be identifying. So here also, if it is not if it is not got, then it will go into the root DNS, correct or not? It will go into the root DNS. This is the root DNS. Let me write quickly. Root DNS. Okay, so this is the particular thing. First of all, it will be searching over here. Okay, it won't finding this one. It will be going through my internal firewall. Okay, so it will be searching this DNS. It won't finding because first time it cannot go. Okay, so then it will be searching in the particular service provider domain DNS. Okay, yes, DNS. I can always specify. Okay, so here it will be checking. Okay, so if at all it is not available, then it will be going to the root DNS. Okay, there it will be going to the actual some other TDLS, okay, TLD domains will be there, right? So it will be checking over there. Already we have discussed. Then it will be sending. Okay, then it will be sending. This one it will be sending to your firewall. From firewall, again it will be coming to your internal firewall. Okay, so from here it will be it will be giving the particular thing. Then it will be updated in your, once if it is visited, then it will be updated, the entry will be updated in your local DNS. Okay, otherwise it has to first of all get the particular things over here, right? So if that is the case, okay, that is what will be happening, right? So if this is the case, right, so this particular firewall, okay, this is what, this is which firewall? Perimeter firewall, right? Perimeter firewall. So this firewall, what does it contain, this perimeter firewall, Eunice? Perimeter firewall, what does it contain?
It contains rules.
Yeah, exactly, correct. That's what I expect. Okay, so it contains inbound rules and outbound rules, right? So whenever, okay, so whenever, so first, for the first time, it has gone to the particular DNS. This is the internal DNS. Okay, this is the internal DNS over here. So this is the internal DNS. Okay, so whenever it checks over here, it won't find. Then what does it do? It will be sending the request over here through the perimeter firewall. So whenever it goes to the perimeter firewall, right? So for DNS, okay, what is the port number? 53. Okay, 53 is the port number, correct or not?
Yes.
Okay, DNS, yeah, 53. So especially in general, everywhere, right? In perimeter firewall, generally we do not have any rules for the port number 53. Why? Because that is understood by everyone, right? Because okay, this is because it will be requesting the particular server. Okay, it will be requesting the particular server. Some server will be somewhere over here. Okay, server will be somewhere, or it will be requesting over here. Okay, so for that thing, because it doesn't understand the domain name, so it will be requesting the particular IP address. That's why there is no need to check. It is the general thing that will be happening. Like that, we do not have specific rules. Okay, in the IDS, where we'll be having, where the detection system will be there, rules will be there in the firewall. The detection system IDS will be having over here, right? IDS, okay, IPS and IDS, okay, intrusion detection system and intrusion prevention system we do have. Okay, so we do not, it won't block. Why? Because there are no rules over here. That's why it will be passing over here and it will be getting and it will be giving. Okay, in general that will be happening. So taking this as an advantage, okay, the intruders, okay, already your system has been compromised, for suppose earlier. Okay, so what they will be doing, they won't send the, they will be, now they will be sending, okay, now they will be sending the request. Actually it has to go first of all to the internal DNS. If it is not available, then it has to go to the external DNS, correct or not? External DNS or the route D or the particular root DNS. Okay, so it won't be sending like that. It will be sending a request directly to their particular DNS. They will be having a separate DNS over here somewhere. Okay, this is the attacker's DNS. Attacker DNS. Okay, so they will be directly, okay, sorry, yeah, so from here they will be sending to the internal firewall. Okay, internal firewall doesn't check anyhow. Okay, so from here again they'll be sending to the external firewall. Not, they bypass this DNS, please observe, they bypass this DNS. Okay, they'll be sending to the external firewall. External firewall, what does it do? Because there is no rule over here, right? There is no rule over here in the, even the perimeter firewall also. Okay, then what does it do? It won't block. So then what they will do, they will be directing this is the IP address that they have given, so it will be going over here. Okay, it's going over here. So what they'll be doing, so in this one they will be stuffing. Okay, they will be stuffing some information, their own information. Okay, which kind of information they will be stuffing? So actually this process is called, whatever the process I have explained right now is called as DNS tunneling. Okay, so bypassing the actual internal DNS, okay, they will be sending to the, directly to the attacker DNS directly with the particular payloads. Which payload they will be sending? I'll be explaining, 1 minute. See, so if this is the particular thing, okay, let me put like this as well. First of all, Okay, so here, so in this one they will be having the, this is the packet. Okay, so in terms of data will be traveling in terms of packets, right? So this packet they will be manipulating now. How? They will be having the source IP address. Okay, from which system? This is your client system, right? Which is compromised one. Source IP address will be having, correct or not? Source IP address. Okay, so similarly here they will be having the destination IP address. Destination IP address. Okay, they'll be having, and again, right? So this is called as the payload. Payload will be, that means the headers. Okay, whatever the headers are there, and again the length of the particular packet. This also they'll be having the length of the particular packet. Length means the actual size of the packet. Okay, length of the particular project. Sorry, particular packet. GTH. Okay, particular project, and again the checksum. Have you discussed about checksum, Eunice? Checksum, Eunice. Checksum, have you discussed? Checksum, how to calculate checksum,
Yeah.
whenever a packet is being sending to the server. All those things we have discussed, Eunice. Yeah, please refer.
Yes, yeah.
Yeah, please refer to the early. See, networking concepts completely. I have told you each and everything. Okay, that's why so many classes. Almost all we are in 30th class or what? I think so. Almost all 28 or somewhere else. Yeah, and actually here they will stuff the data. Okay, so let me put this one again. So here they will stuff the actual data, whatever the data that they want to send it to their server, okay, to their DNS. Okay, they will be sending. So this is called as the payload. What is this is called? This is called as the payload. So a payload is nothing but the combination of headers and the actual content. Payload.
Source port
Okay.
is not there.
Yeah, what is that?
Source port, destination port number.
Yeah, this is what, this is source IP or source port, whatever you may consider. Okay, so all these things will be having the length of the particular, the size of the particular packet. Okay, the checksum value that will be passing. Okay, in order to validate they were there on server, right? So that thing and the actual data. So all those things will be calling it as payload, and it will be sending it to their servers. So now once if it is sent, right, now they can manipulate. Okay, now the communication properly happens. Okay, so each and everything, whatever the data that receives on your computer, okay, so they can always send it to their particular servers and all. So this process is called as DNS tunneling. Okay, so they bypass your actual, whatever the regular process that it has to happen, they are bypassing that one. How they are bypassing? Because they have compromised this particular system, and because they do have this particular advantage where the perimeter firewall doesn't have the signature of the particular DNS server. They do not have the signature of this particular port number 53, right? They having advantage of that one. They are what we say, without just like a king. Okay, they are passing through your internal firewall, they are passing through the perimeter firewall, and still they are able to go to the particular DNS, their own DNS. Okay, and they are getting the data. This process is called as DNS tunneling. Is it clear what is done by DNS tunneling, Krishna?
Yes. Yes.
Krishna, are you there?
Yes, yes.
Yeah, so now, okay, what we have understood, let me complete. Okay, so otherwise again it will be left. Okay, so in order to remediate this kind of DNS tunneling attack, okay, not to happen, what we have to do? Let me take a new page. Okay, so what we have to do? First of all, what we have considered. So why it is happening? First of all, Eunice, why it is happening? What are the steps? Now you tell me, what are the steps that we have to take? You know, because you understood.
We need to create the rules in a firewall.
Right, because there is here the actual thing lies, right? Because they identify that nothing is there over here, it is simply passing, because nothing rules are related to the, in general they won't be having. Okay, so that kind of systems only they will be compromising, right? So they will be they'll be choosing this type of systems where there are no actual rules in the perimeter firewall as well. for the particular port number 53 and all. So they will be having the DNS tunneling attack. So now what, as a cyber security analyst, what you have to do, you have to first of all, okay, you have to first of all, let me increase the size as well. So you have to first of all, what you have to do, you should not allow end users to the DNS request to the external IP. Okay, so you should not allow the user. Okay, you should not allow the user to send the DNS request to the external IP directly. So here what is happening, actually they are directly sending to the external IP only without bypassing this particular DNS. Correct or not? Then they do this particular one and they are sending because of this particular thing. That's why you have to first of all do, you should not allow okay, end users to send DNS request to external IP directly. DNS request to send to the external IP, right? That is what you have to do. So how this is possible? So simply for specification sake, I have told like this. But how it is possible? How it is possible? So it is possible, right? Whenever, okay, if there is a outbound traffic, if there is a like this, you have to specify in the firewall. So if it is a outbound traffic, okay, you have to identify that is a outbound traffic. That means from inward to outward it is going, okay. And if source IP is not equivalent to destination IP, this destination IP is different and source IP is different, right? Is not equivalent to source IP, and port number is 53. For such things also, earlier for such things there is no rule actually. Whenever for this also, if it is a proper request, DNS request also, the source IP will be different and the destination IP will be different. But it is first of all going to DNS and this is checking, okay, and it is going. So here now what we have to do, now also it is different, right? The source IP is different and the destination IP is different, and port number 53, okay, if there is a source IP which is different and destination IP is different and port number 53, then you have to write a rule over here, okay, if it is outbound traffic that is happening, okay. So that is the thing that you have to do. In that way you can always eliminate, okay. So that means what you can do, if that traffic, okay, if the traffic is outbound traffic, and okay, outbound traffic, and if source IP, okay, is not equals to destination IP, okay, and if the port number, this is how we can always recognize, right? Port number 53 and the port number is 53, then update the signature, okay, update the signatures, okay, write a rule, then write a rule, whatever it may be, okay, write a rule, correct or not? So this is the thing that we have to do, okay. So, and again, apart from this, so this is the first thing, right? This is the first thing. Immediately by seeing itself, we can always specify. And second thing, what we have to do, so signatures where will happening in the DNS, okay, in the IDS, okay. So IDS should also be updated with the proper signature. So once if such kind of thing happens, a signature should be there. So IDS should also be updated with the particular signatures, correct or not? IDS should contain DNS signature. IDS should contain DNS signature, okay. This is the second thing that you have to do in order to mitigate this kind of DNS tunneling, okay. And third thing, which is the most important thing, what you have to do, so whenever you find, okay, a lot of DNS query messages from a internal machine, okay, from a static internal machine, okay, or constantly over a period of time, okay. See, in general what happens, if at all it is a natural DNS request, so only whenever you request, right, only once only it will be executed, right? So it will be going your, even if you are executing for the first time, okay, it will first of all checking in your local DNS. If it doesn't found, if it is if you are requesting for multiple times, automatically it will be updated in your local DNS. From here itself you can always get the response, okay. But whenever you, even though if you consider that you are using for the first time only, so it will be going over here, it won't be finding over here, it will be going over here or here to the root DNS, okay, and it will be getting and it will be updating in the DNS, okay. That what it is a one-time process. But what these people will be doing, because this is the, they are transferring the data with your source IP and destination IP with the port numbers, all those things, right? So they will be constant, frequent data transfer will be happening between their DNS and the particular compromised system with the victim, we will be saying, okay, with the victim and the particular DNS, okay. Lot of communication will be happening, okay, not only once, okay, lot of communication will be happening. So that is what you have to detect, okay. So whenever a lot of DNS queries are transmitted, okay, so lot of, if lot of DNS query messages, okay, are transmitted from a static, okay, machine to the external servers, okay. So constantly, that is what important, okay, constantly over a period of time. Then what you have to do, you have to detect such thing, you have to write a alert, okay, over a period of time. So how we can write alert, which condition? Simply we have said in general terms how we can write. For example, say in 4 hours, okay, in 4 hours, sorry, in 4 hours, okay, you have got DNS requests, okay, DNS requests are coming from a constant machine, okay, in 4 hours from a particular machine, from a IP address, okay. So more than DNS 300 DNS requests have gone, okay, to a particular destination IP, 300 DNS requests. This means what? In general this happens. Does it happens in general? In 4 hours 300 DNS requests will be happening, or else in 1 hour some 50 DNS requests will be happening? It won't happen, right? DNS request happens only once, right? Once if you get it, it will be updating your local system, okay, that's it. So whenever you are accessing that particular website, again from your local system only it will be getting, it won't even go to your perimeter firewall also, it won't cross there also, right? Because it will be available in your local system, okay. So that is how, okay. So you can always have this kind of particular checks, and you can always access, okay, you can always restrict the particular DNS tunnel attacking and all, right? So that is the particular thing that you can always do, okay. You should not allow the end users to send DNS requests to the external IPs. How? By knowing the source IP, destination IP, okay. Whenever it is not equal and port number 53, you have to write a rule, okay. You have to check whether a rule exists or not in your particular perimeter firewall, okay. So if it is not existing, you have to write a rule over there, and again you have to maintain signatures, okay, for the previous such type of things that happened, or else this kind of things will be happening. Signatures will, you have to append where? In your particular DNS servers, okay, in your particular, sorry, in your particular IDS, okay, about the particular DNS, we have to update the signatures. That is second thing you have to do. And thirdly, whenever a lot of DNS requests are happening within a specific period of time from a static machine, just like for a 4 hours, if you have more than 300 DNS requests, you can always block such kind of requests in the firewall itself, okay. So by doing all these things, you can always have the particular DNS server DNS tunneling attacks halted, okay. So you can always mitigate this kind of attacks. Is it clear for you?